Hello everyone, my name is Junwen Liu. I'm a PhD candidate in Computer Science Department of Wayne State University. This is my third year enrolling as a full-time PhD student. Before that, I was a software engineer in Henry Ford Hospital in Detroit for 5 years. Today, I'm going to present our survey with the title, A Survey of Modern Scientific Workflow Scheduling, Algorithms and Systems in Era of Big Data. Firstly, let's take a look at the key contributions we made through this paper. In this succinct survey, we'll provide an overview of the workflow scheduling, especially with regard to the parallelization techniques that are used in the scheduling algorithms, as well as the challenges in the current scheduling algorithms in the cloud. And also we proposed a new and practical taxonomy of the workflow scheduling algorithms in the cloud that identify 4 categories of the scheduling algorithms by considering 2 dominant factors. One is a mixed span, one is the cost of workflow execution. These 2 factors we believe are very dominant concern currently be considered in the cloud execution. We also surveyed in depth on 10 state-of-the-art workflow scheduling algorithms in clouds, which are support large scientific workflow execution. We further reviewed 5 representative scientific workflow management systems in light of their usability, the prominent features, as well as compare them with few key specifications. So here is a presentation outlines we will walk through in today's presentation. Firstly, we will take a quick look at overview of workflow scheduling, and then we will introduce our proposed taxonomy of the workflow scheduling algorithms. And further, we will examine example structure of the survey we conducted on 10 state-of-the-art workflow scheduling algorithms in accordance with our proposed taxonomy. Next, we will examine one example structure of the survey we conducted on 5 selective representative systems. Furthermore, we will provide a summary of all other representative workflow scheduling algorithms in accordance to the taxonomy we proposed. In total, we have 25 algorithms in that table. Similarly, we will list other 10 representative workflow management systems in that table, other than the 5 systems we reviewed in depth. Lastly, we will come to the conclusions and discuss the future work and acknowledgements. Firstly, let's take a look at the overview of workflow scheduling. The first question may come to what is workflow scheduling. Basically, workflow scheduling is a procedure that to map the workflow tasks to computing resources. For example, in the cloud, we are talking about virtual machines that are needed for the task execution. And then, what is the goal of the workflow execution or workflow scheduling? Basically, the goal is to get an efficient scheduling plan, which can also be called as SP, that optimize certain constraints or objects, such as minimizing the mixed span or minimizing the monetary cost. Other than the general overview, we also encounter some challenges of workflow scheduling in the cloud nowadays. For example, we have to come up with a suitable scheduling strategy, which is going to be a trade-off between the cost and efficiency. Why we say that? Because in the cloud, we are using a utility-based service. That means we have to pay before we get some service with different capabilities, based on different price tag, of course. So that requires us to balance the cost as well as the efficiency. Furthermore, we have to think about resource provisioning and deprovisioning strategy. That includes how many virtual machines and what type of virtual machines that are needed at a certain time, based on the various billing model that are available on different cloud suppliers. Also, we have to take dynamic cloud computing environment into consideration when we do the scheduling. That is one key point at this moment, because the performance of VMs or the performance of network in the cloud can vary time from time. Now let's take a look at the overview of existing workflow scheduling taxonomy. So far, there are three classes of workflow scheduling strategies in traditional taxonomy in terms of on which phase to generate a scheduling plan, or SP. So here we have the static, dynamic, and hybrid. The static means we generate a scheduling plan before the execution. A dynamic means we interleaving the scheduling with execution, so together we do the scheduling while the execution. Well, the hybrid means that some algorithms may have static components as well as some dynamic components at the same time, so they are working together to carry out the scheduling. Also, we have four types of workflow scheduling approaches so far. For example, like the task-based, which are basically scheduling task by task. We also have the path-based, basically they are scheduled path by path. And we also have BOT-based. BOT stands for bag of tasks. That means we are going to schedule a bag of tasks or group of tasks at once. Also, we have workflow-based scheduling approach, which basically is scheduling workflow by workflow. On the other hand, in terms of building models in the cloud, we mainly have two categories. One is a fine-grained building model, which means we are charged based on exact time we are using on the virtual machine. For example, like dollar per minute. And there is another type of billing model, which is coarse-grained, that is charged by billing cycles. For example, like dollar per hour. Even though we may not have fully utilized a billing cycle, we will be charged by the price of the whole billing cycle. So that is one thing we have to keep in mind when we do the scheduling. In this type of billing model, we have to fully use the billing cycle, and we don't want to waste any redundant time that we have been paid already. So here is the new taxonomy of workflow scheduling algorithm we proposed, and we mainly consider two dominant factors. One is max span and one is monetary cost. And we differentiate four scenarios of the workflow scheduling algorithms. So for the category 1, we give a deadline and then we try to minimize monetary cost. For the category 2, we give the budget and we try to minimize max span. And for the category 3, we try to give no constraints, but we want to minimize max span and or the monetary cost. And for the category 4, we're given both deadline and budget constraints, and we try to optimize some other performance metrics. We made in-depth survey on 10 state-of-the-art workflow scheduling algorithms, and basically here is one example structure on one of our in-depth survey on algorithms. This is an algorithm ICP-CP, and in accordance to our proposed taxonomy, this is an algorithm of category 1. So all the other algorithms will follow similar structures. Basically, we will go through the scheduling approaches. For example, whether it is a path-based, or it is a task-based, or it is a BOT-based, etc. Also, we cover the scheduling strategy. Basically, whether it is static, whether it is dynamic, or hybrid. And we also cover the assumption of the computing environment. For example, like what kind of virtual machine this algorithm support, and whether they are heterogeneous or homogeneous, and what kind of model, the storage model we can adopt, and what kind of billing model can be used for this algorithm. Furthermore, we have the performance matrix, that is to assess the performance of the scheduling algorithms. And we also have the complexity in terms of the time complexity to be taken for the algorithm to run. Last but not least, we have the main idea of every algorithm, and we take a whole paragraph to illustrate the main idea of every algorithm in a compact profile. We try to make them succinct so that the new researchers are able to quickly grasp the main idea of each algorithm, so they don't need to refer to the original publications, and this is one thing for the algorithms we do on the survey. And we also have a table that is present a side-by-side comparison among these algorithms in terms of, for example, constraints. in terms of objects, types, scheduling strategy, whether it is static or dynamic or hybrid, and time complexity. And similarly, we have a structured example of our survey on the workflow management system. So all the other systems are in a similar structure. Basically, we will go through the specific target domains for each management system because they usually focus on different domains and used by different domain scientists, and what kind of salient features they have. For each one of them have different focus, and each one of them focus on different research issue. So they may have different requirements. And further, what kind of execution environment they support, whether they are executing in the cloud or they are executing in the grid, or they can execute on whatever environment you have locally. Furthermore, we review on what kind of language support they have, for example, like Java, like Python, like Perl, and whether they have the API support or whether they are open source. And finally, we list the scientific contributions in the last paragraph. So all the other systems are reviewed in a similar structure, and here is a table that compares side by side the systems in terms of their domain execution environments, whether they support software as a service, and what are their user interface, whether it is a graphical or it is from CMD, and whether they support API, and whether they have any language support for further development. We also attach a link or URL for download the software as well. So here is a final table that summarizes all the representative scheduling algorithms by our proposed taxonomy. As you can see that we have 4 categories, and we have 25 algorithms in total in this table. We try to find the state-of-the-art algorithms in each category and help the new researchers to quickly pick up what kind of algorithms they need to read in depth. And here we highlight algorithms we surveyed in depth. We also list out other representative systems, including the 5 we made in-depth survey on. So here we have in total 15 systems in the table. Well, here comes to the conclusion and future work. In the survey, we started from a general introduction of the workflow scheduling problem and proposed a new taxonomy of the workflow scheduling algorithm in the cloud, and will provide in-depth review on 10 state-of-the-art workflow scheduling algorithms in the cloud and 5 representative workflow management systems. For the future work, we are trying to introduce AI techniques in the workflow management systems, aims to mutual improvements between the AI and workflow management system, because we know the AI, especially deep learning, still has many black boxes, and we try to have the workflow management system to fine-grain the processing and try to further explore the deep learning with workflow management system or the provenance data. As well as we have the AI can help the workflow management system, for example, to fine-tuning the hyperparameters. For example, like what kind of virtual machine they need to be assigned and what kind of scheduling algorithms they want to adopt. So lastly, I hope to acknowledge this work, especially partially this work is supported by the National Science Foundation on the grants CNS 1747095 and OAC 1738929, and also many thanks goes to DataView team members for support on this work. So that's pretty much for today's presentation, and thank you so much for your time. Hope you enjoy, and see you next time.